Hi, hello, my name is Brandon, the Algebra Guy. Today we're going to be covering multiplying fractions step by step as you see here in the picture. I want to first start out by modeling what does it mean to multiply a fraction. So we can get into the mathematics and the processes, but what does it mean to multiply a fraction? I'm going to use a rectangular fraction bar, if you will, to show that. Then we'll get into multiplying some fractions according to the multiplying rule for fractions. So as usual, I'm going to start up with my questions that we're going to answer for today. Today we're going to answer these questions. How can multiplying fractions be modeled? What is the rule for multiplying fractions, and how do you multiply fractions with whole numbers? So let's jump into it. How can multiplying fractions be modeled? So a model may help you understand multiplying fractions. We're going to use the fraction tiles to model 1/2 times 3/4. So to multiply 1/2 and 3/4, think 1/2 of 3/4. So we're going to start with 3/4. And to model 3/4, I'm going to pull up this chart here. So here's fourths. And I want how many of those fourths? Well, I want to start out with 3/4. So I'm going to shade in 3 out of those 4. And then the question says, what is 1/2 of 3/4? Because oftentimes when you're multiplying, when you read it back, the word of will be in place of where the multiplication will be. So 1/2 of 3/4, we can just draw a line straight down the middle of this bar, and that takes half. Well, when I shade in half, particularly where the 3/4 is already shaded, here's what I come up with. So we end up getting this dark blue shaded area here, and that's really our answer. Well, what do you mean that's our answer? Well, think about it. So the pieces that are shaded in are 3, right? 1, 2, 3. Out of how many now? How many total? Well, when I count them all up, I have 4 on top, 4 on bottom, so that's 8. So my answer would actually be 3 out of 8. So if I were to multiply 1/2 times 3/4, it'll be 3/8. And let me just talk through that real quick again. I took 3/4 and I took half of 3/4. I shaded everything in. Where they crossed is where I want them to answer. Now, I would have shaded this part in too, right, for half, all of this stuff on the bottom. But where they crossed was right here in this section. So that's 3 out of a total of 8 boxes that were created. So that's the visual for what's going on when you're multiplying fractions. You're taking a cross section, if you will, of those two fractions. We could have gotten the same answer by multiplying the numerator and multiplying the denominator. So here's a faster way we could have done it. 1 times 3 is 3, and 2 times 4 is 8. So that's good to know, right? So you don't have to draw a model for every single time you try to work a multiplication problem. So here's the rule. When you have two numbers, a over b times c over d, what you're really doing is just saying a times c, those two together, and b times d, these two together. That's really all you're doing with multiplying. You just go straight across, and that's really the easiest thing. It's probably the easiest of all the fractions operations, adding, subtracting, multiplying, division. This is probably the easiest to work with because you just simply go straight across the top and bottom. Multiply and write the answer in simplified form. So I want to give us 3 practice problems before going here. So let's try this one. With the new rule we have, we don't want to draw a rectangular model and try to figure this out. Let's take the rule that we have to multiply this. But before I do that, I noticed that I'm multiplying a negative number times another negative number. And do you remember the rule? What happens when we multiply negative times a negative? Well, if we got the same sign, it's going to be positive. So I'm going to rewrite this as 5/8 times 2/3. Because that negative sign is going to go away to a positive now. And now, remembering my rule, 5 times 2 will give me 10. And 8 times 3 is 24. They also said they want a simplified form. Is this simplified form? Well, referring back to our previous lesson, and if you didn't remember or did not go over that lesson, I would encourage you to do so. But how do we get this to be simplified or reduced if it's not already? Well, I hope you're saying it's not, because they're both even, so I know they have a common factor of at least 2. So knowing that, I'm going to write this a little bit bigger. So knowing they have a common factor of at least 2, and I think that's the biggest because we got 2 times 5, and 24 doesn't have a 5 as a factor. So probably the biggest is 2. So I'm going to rewrite this as 2 times 5, and I'm going to rewrite this as 2 times 12. Same thing, nothing changed, but now that allows me to see that I can cross out my 2, because 2 divided by 2 is just 1, and I'm left with a simplified fraction, even though they want a simplified form, of 5 over 12. See, 5 and 12 don't have any common factors in it, so now this is considered simplified. All right, let's go to our next one. What about this one? Negative 14 over 15 times 20 over 21. How do you work that? So I'm going to rewrite it down here just to give myself some more space. Negative 14. Oh, that's too little. I could do better than that. Negative 14 over 15 times 20 over 21. All right, so we want to, the idea is you can just multiply straight across. 14 times 20, 15 times 21. Easy peasy, you're done. But since we want to simplify, I'm going to go ahead and start looking for ways I can simplify this. So let's think about ways we can do that. One of the ways you can do that is, let's get this ready. This is negative some fraction. So we can break this down into its factors, which is 7 times 2. And since I know I'm multiplying 20, I could break 20 down into some factors as well. I could break it into, let's see, I'm trying to get the most prime factors would be better. I could break it into, just for visual purposes, I'm going to stick with 5 and 4. Now I wanted to do 2 times 2 times 5. Actually, I'll go ahead and do that. I'll do 2 times 2 because that's the same thing. Now that you've seen, that's what I did. So 5 times 2 times 2 is 20. So you see this top part is the same thing as 14 times 20. But why am I doing it this way? Because I'm going to go ahead and try to simplify it all at once instead of getting this really big number, 280 up top, and then, what is this, 321. So let's see, maybe 321. So I don't want to get those big numbers. I'm going to go ahead and start breaking it down into its prime numbers to see if I can get some numbers to cancel out on top and bottom. So what about 15? Can I get that into some prime numbers? Yeah, that's pretty simple. 3 times 5 gives me 15. And what about times 21? What can I break that into? Well, I can break that into 7 times 3. All right, now let's look at this. We haven't done anything but break them down into their factors. So we just broke them down so we can start eliminating some common factors on top and bottom. So let's look and see if we have any common factors. I got a 5 down here, I just noticed. Let me get let's use red for this. So I have a 5 on the top and bottom, so I'm going to cross out these 5. Oh, that's a great feeling to start crossing out these numbers. I have a 7 that we can cross out. That's another great feeling. And 2 times 2 is 4, 4 times 2 is 8. So no, that's not going to work. So what do I have left? I end up with a negative. And let's still use yellow. 2 times 2 times 2. Well, that's 8. 2 times 2 is 4, 4 times 2 is 8, and 3 times 3 on the bottom. And let me double check this. Is this simplified? Does 8 and 9 share any common factors? Well, I'm thinking about that. That's 4 times 2 and 3 and 3. No, they don't have any other factors in common. So this is indeed the best or the simplified form, the most reduced and simplified. Now, I could have simply just multiplied straight across 14 times 20. And I think, like I said, that gives me 280. This is going to be negative still because that negative sign. And then 15 times 21, which I believe is going to give me 315. This is a guess. Let's check. 20. I'm pretty sure that's 315. So look at this number we would have gotten. And then we would have had to simplify that. So we're going to end up doing the same thing anyway of breaking that 280 back down into these numbers, maybe using a factor tree or something to start breaking it down into its prime numbers. But we went ahead and did that with the smaller numbers. 7 times 2 is 14 times 5 times 2 times 2, which was 20. So we just put them all together and start canceling. What a great time saver. And you may be able to get to the point where you can do that mentally once you've done enough of these. Matter of fact, why don't you try this next one? 1/7 times 56. Well, that seems pretty straightforward. All right, 1/7, going to rewrite this here, times 56. Well, 56, I know how to multiply fraction to a fraction, but how do I do a whole number? Well, 56 can be rewritten as a whole number because 56 over 1 is the same thing as 56. These are equal. 56 divided by anything divided by 1 is just that same number. So I can create a fraction which doesn't change its value and then implement my process for multiplying fractions. 1 times 56 is 56. And that's 7. So now I got 56 over 7. But is it simplified? Well, let's see. What are the factors for 56? I have 8 times 7. And this is 7 times 1. The 7s can go away here. Now I'm left with 8 over 1, which is the same thing as just 8. And there we have it. So really this will end up being 56 divided by 7, which is just 8. And that's how you do that one. All right, let's do this one here. I believe I said 3, but I guess it's 4. So what about this one? This is not a fraction, but we want to multiply so we can change it into a fraction. So we can make this 12. Let's start over here this time. 12 over 5 times negative 20x all over 1. So that we can see that this is a fraction. Now I'm going to treat this like I did the other problem and start breaking it down into this prime factors. And if you can't think of the prime factors, just start breaking it down anyway, and it'll come together a lot faster than just trying to get the big number oftentimes. So let's do 12. That breaks down into 3 times 2 times 2. Because 3 times 4 is 12, and those 4s break down to 2. And I have 5. And I'm going to change colors just to show you that I'm bringing both of these fractions together. So now, and I'm going to keep this negative. I don't want to forget about that negative because negative times this positive is going to keep this whole thing negative. What about 20? Well, 20 goes to 5 times 4, 5. And instead of 4, I'm going to give those 2's again. So make sure everything is as reduced as possible. And then I just have a 1 there. So what can we do to simplify this? Well, there's not a lot on the bottom to simplify. This is just a 5. And fortunately, we do have a 5 up there we can cancel out to make this a little bit simpler. So let's multiply what we do have left. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is, I believe, 48. 16 times 3. Yep, 48. And that's going to be over nothing. So just over 1. So our answer for this is just negative. Oh, I forgot my x. So it should be negative 48x. I almost messed that up. Don't forget the x. So we should have said all that times x. And there's no way you can break down x. It's just going to be x. Unless it was x squared, then we can say x times x. But it's just x. So we're going to get negative 48x. Bam. That does it. How can multiplying fractions be modeled? We did that with the rectangle. We saw with those two colors crossing over each other, and that gave us an answer. What is the rule for multiplying? Well, if you got two fractions, just multiply straight across. 5 over 7. What you going to multiply? 3 times 5 and 2 times 7 in this case. What about whole numbers? Well, if you got a whole number you're multiplying times 5, just rewrite it as a fraction by putting a 1 in the denominator. And then you do the same thing straight across and you get your answer. Thank you for tuning in. My name is Brandon Clayton, the Algebra Guy, and I'll see you next lesson.